So before I dive in, I want everyone to try and bear with me here for a moment and imagine you're 10 years old and you're sitting at your family dinner table just like you do every night, and you're talking with your mother, your father, brother, sister, pretty much about what went on that day when you realize that Mrs. Dudley, your science teacher, she was your favorite teacher. She told you that there's an upcoming science fair. Of course, you want to participate, so you ask your dad for some guidance. Well, of course, he was pretty thrilled to lend a hand, and he asked what your ideas were. And you were ready for that one. You said, "Dad, I want to build an elevator." Now, your dad, he looked briefly confused for a little bit there before replying that he doesn't really think that is a science project. You were also ready for that one. You said, "I want to create a 3-dimensional elevator." Your dad, he looked pretty darn confused still, so you continued on and you said, "I want to create an elevator for the world's laziest people." See, this elevator would not only move vertically as normal elevators do, it would also move horizontally in both axes, up and down the corridors as well. No need to walk up and down those hallways anymore. This elevator, it would take you right to your door. And we'll talk about that more later. At any rate, my name is Jonathan Foremny. I hope everyone is enjoying the beautiful city of Long Beach, California, as much as I am. I don't want to go too much into my background here, but I think one thing is important to mention, and that is I like to think of myself as having a relatively unbiased view of the aviation sector as a whole. So I have my hands in a number of really seemingly disparate socioeconomic sectors that have somehow managed to weave themselves into my life through aviation. So I began my foray professionally into aviation working for the Federal Aviation Administration. I worked for the Beyond program there, working to integrate drones into the national airspace system. Moved into the private sector, flying as a test pilot throughout the country for a number of years before returning to the East Coast, settling right on the Chesapeake Bay, just north of Washington, D.C., where again I work as a test pilot, an airworthiness integration engineer, and an adjunct professor of commercial flight planning and management. So I'm involved in the private sector, the government sector, and also education. But my truest and most fundamental purpose is to utilize aviation in a capacity that in some small way makes the world a bit of a better place. And it's crazy to think, but the way I have found that I think I can do that best is by investigating the societal and economic benefits of systematically integrating beyond visual line of sight uncrewed aircraft system operations into the national airspace system, and even more specifically into urban infrastructure. So this is just a brief agenda. First, we'll talk about what BVLOS operations are exactly and why they matter. Talk a little bit about the societal and economic benefits of uncrewed aircraft before we move in to a discussion about what I consider a modern-day smart city. And finally, we'll get to that AR-enabled solution. But before we do dive in, I think it's important to discuss what this title means a little bit. And there are 3 components to the title I want to discuss in particular. And the first is the notion of systematic integration. When I'm talking about systematic integration, I'm talking about creating a regulatory structure wherein UA, uncrewed aircraft, are integrated into the national airspace system based on rules. Currently, under FAA Part 107, which regulates commercial drone operations, we have a waiver-based system. So every time we want to fly BVLOS beyond the visual line of sight of the operator or of the pilot, we have to file a waiver, and it's a pretty complex waiver process. The second thing I want to talk about is complex airspaces. This, in this context, doesn't actually have anything to do with airspace at all. When I mention complex airspaces, I'm just talking about the volume of air that either directly overlies or is immediately adjacent to cities. Which leads us to societal and economic components. Why did I choose to investigate societal and economic components when I could have chosen anything out there? And it all happened really when I was lying in bed one night, and actually I guess in the name of transparency, it's lying in bed every night because I just can never get my mind to turn off. So I was lying in bed and I decided to be productive, so I thought, what components maintain the potentiality of changing society in the most meaningful and powerful way possible? So I thought, and I came up with some adjectives. So first one is courage. I think this is a good one because in order to evoke true, meaningful, and lasting change, we have to be courageous. I don't think Significant change can occur if we don't step outside of our comfort zones, and in order to do that, we have to act courageously. Next is consistency, and this is really true for anything, right? We're not going to lose weight if we don't consistently diet. We're not going to gain muscle if we don't consistently go to the gym. We're not going to evoke true, meaningful, and lasting change in the uncrewed sector and adjacent industries if we don't act on a consistent basis. And conviction. I love conviction because it means we don't always have to be right. See, when we have an idea or a construct we want to investigate, I think that's important that we put 100% of our energy into that idea. If we do that, the end result doesn't really matter. We get to the end, it's a big breakthrough. Of course, that's fantastic. If it's just a dead end, it's a dead end, and we can completely push that idea aside. So that's conviction. And clarity, because if we're not thinking clearly, well, what are we really doing? But there was something very, very wrong with all of these, and that is that they were abstract. They weren't really tactile in any sense of the word, and it wasn't until a number of days later when I was Googling them that I came to find out that some of them are actually part of the big Seas of Change catalysts. And if you need to know anything about me, it is that I hate gimmicky slogans like that. So naturally, we're going to wipe those guys out. Now, eventually I came to think, what is capable of disrupting day-to-day life on the largest possible scale? Well, I'm not very political, but ask any politician. Societal and economic change are proverbial gold mines in any campaign. Figure out how to change society for the better. Maybe do it through economic growth. And if you do that, I think you are well on your way. So that is how we end up with this mess of a title. Oops. Give me a second here. Computer's being weird. Okay. Now, I want to talk briefly a little bit about the aviation sector. So, in my opinion, the aviation industry is probably the most complex socioeconomic sector in existence today. And similarly, I think the United States, the European, and the Asian airspaces are probably the most complex in the world. Now, there were a number of regulatory evolution type events that really compounded these complexities. And I'm not going to go into too much detail here because I think we're going to be pressed for time. But basically, in the United States, commercial drone operations were really pushed into existence in 2016 when the FAA came out with 14 CFR Part 107. And it's been really evolving since then. And a very similar process has occurred in Europe. And actually a fairly different process has occurred in Asia. But we're all kind of coming to the same conclusion that we have to operate UAS on a comprehensive rules-based framework. The waiver system is just not efficient enough in order to really maintain change. So as a result of regulatory ambiguity and as a result of political intricacies, I think the uncrewed sector has become overly and unnecessarily complex. I do argue that by switching to that rules-based system, regulatory simplification will foundationally occur. So through systematically integrating these BVLOS ops into complex environments, I think we can really create some societal change. Now, in order to address the regulatory and the technical integration issues, I think that a number of critical research questions have to be addressed. And I have 4 research questions in particular that I've spent the last 3 years addressing. Those specific research questions are a little bit out of scope for this particular presentation, so I'm going to gloss over those just a little bit. But I do think that, again, one point is worth mentioning, and that is whenever I begin that inquiry, academic, professional, personal, or otherwise, I do think it's super important to lay out those research questions because it allows you to investigate some rather complex topics through some rather simple avenues. Now, that isn't always to say we reach the end goal of what we started out wanting to achieve, right? It's the whole story of Post-it notes. A bunch of brilliant material scientists, they get together trying to develop the world's strongest super glue, and instead they create the societal icon that is Post-its. So anyway, this is a rather complex topic, but I'm hoping I can explain it in a fairly simple way. So, now that we have all of the boring stuff out of the way, I want to talk to you for a moment about elephants. So this is the story of the blind men and the elephant, and this is a parable that came out of the ancient Indian subcontinent. It's probably I guess, made more famous by a wonderful children's book by Lillian Quigley. Anyway, a bunch of blind men are taken to see an elephant as they're blind. The only way that they can learn about this elephant is through touching it. Of course, they touch different parts of the elephant. They all reconvene afterwards, excuse me, and they discuss what they felt. Of course, they all disagree vehemently about what this elephant looked like. So, essentially the moral of this parable is that people's understanding is inherently limited by their perspective, even physiologically. The portion of the electromagnetic spectrum that we can perceive as humans is very, very small. The visible light spectrum, for instance, it ranges from approximately 380 nanometers, which is going to shoot a shade of violet, to 750 nanometers, shoots a shade of red. Anyway, this span here only accounts for 35 10,000ths of 1% of the entire electromagnetic spectrum. Now, of course, humans can perceive the world in more ways than one: touch, taste, etc. But with regard to visible light, we are only aware of a very, very small portion of the entire electromagnetic spectrum. So, I think the other point here is that people often tend to claim absolute truth based on their limited experience. And that's something that we always have to take into consideration when we're talking about developing a regulatory framework, which is really in earnest what we're doing here. So, why am I talking to you about these elephants? Well, the reason manifests in the form of UTM in the United States, that's uncrewed traffic management, or U-Space, which is the U-Space regulation that essentially does the same thing over in Europe. So there are a lot of, once more, seemingly disparate components that make up this uncrewed traffic management network. So of course we have pilots, we have manufacturers, we have service providers. What else do we have up here? Operators, the general public is a very important one, regulators, and public safety officials. Now, for the fun part. I could have very easily chosen any city as the backdrop to this AR investigation, but that wouldn't be super fun, so let's use our beautiful host city of Long Beach, California as the backdrop to our airspace integration exercise, and that's exactly what this is. So we're going to talk about my proposition for integrating drones into cities. So we're going to start out with the general overview, and we'll get more and more granular as we move through this. So the first stratification layer is going to be our low altitude airspace. This is that UTM managed airspace. And in this airspace, we're going to have drones flying along. And as you see, we've got a couple drones flying along here, and they're staying within this low altitude airspace. Fairly unorganized with the way that they're moving throughout that airspace, but they're staying within the airspace. Now, this airspace is going to occupy 0 AGL, so that's 0 feet above ground level, all the way up to 400 AGL, that's 400 feet above ground level. And the reason I chose that is because that's currently really the maximum altitude for uncrewed aircraft without getting a special waiver or without special circumstances being implemented into a specific operation. So at that 400-foot barrier, we're going to have this 100-foot vertical separation zone that goes from 4 to 500 AGL, and above that, we're going to have AAM managed airspace. So this is urban air mobility, and here we have an airspace stratification layer between 500 AGL up to 6,500 AGL, and here we're going to have our air taxis. So these are larger advanced air mobility vehicles, and that's great, but there is one complicating factor here, and that is in this stratification layer, we're also going to have crewed aircraft. So we have a couple Augusta 109 helicopters there. I'm flying my Cessna 195, taken in the view of Long Beach. Again, everyone's staying where they should. However, not exactly super organized within that layer. The other layer, the next two we're going to talk about, are the transport, cargo, IFR, ATS. So this is our standard air traffic system, heavy lift, cargo, and air transport jets. I'm not, again, going to talk a lot about this, but this layer, I propose to go from 6,500 AGL all the way up to flight level 600, which is 60,000 feet. And that's the floor of upper class E traffic managed airspace. This is where we're going to have high altitude stratospheric weather balloons. This might be where we have solar drones. So now let's talk a little bit more about that UAM traffic management corridor. So I propose that we stratify the airspace further based on aircraft direction of travel. So all aircraft traveling west are going to be in one specific layer between two specific altitudes, same for east, south, and north. So we are flying, let's get some of these in here for realism purposes. All right. So now we are flying along, woke up for work, and hopped in our air taxi. And where's our air taxi? All right, so we're traveling south, and we want to change direction. Well, we can't just go busting through the floor of that southbound airspace. So we have to figure out how we want to be able to change direction. Well, I propose a system of corridors and nodes. And this is where we're going to bring back that three-dimensional elevator we talked about at the beginning. And if you haven't already guessed, your three-dimensional elevator is actually my three-dimensional elevator that somehow made its way back into my life after a 24-year hiatus. So essentially what I did is I created a structure of a building. This was, again, when I was back, I guess I was about 12 years old, for a science fair. I created a structure of a building out of these cool PVC pipes, some plastic sheets, and I found this solvent that chemically melts the plastic, and I basically could build the frame of an office building. Bent up a piece of sheet metal into a little cube. That would be the elevator car, and basically pulled this car in all three dimensions using electromagnets. So just basically a bolt with some very fine wire twirled around it. So now that we got to our office building, we're right over it here in our AAM vehicle. How do we get from where we are here down to the roof of our office building? Well, again, we can't just go busting through the floor of that airspace, so we have to create a new type of airspace structure. And here I like to term these vertiports. This is the UAM vertiport. This will allow us in our aircraft, with the blessing of the appropriate air traffic authorities, to transgress through that 100-foot vertical separation barrier through that UTM managed airspace and land on our office building. Now, of course, that's all well and good. But what do we do with that UAS sector? Well, we're going to do the same thing, stratify by direction of travel, create a couple vertiports, and our drones can operate safely in that airspace as well. And again, this is integrated airspace, so we're not operating in a segregated fashion anymore. We're integrating crewed aircraft, we're integrating drones, and we're integrating AAM vehicles. Now, how does all of that relate to XR? Well, to answer that, I want to start off by showing you two applications that are already fairly well refined, and those are Starwalk 2 and Flight Radar 24. Now, there's a number of relevant features to these apps, but I want to focus on the point at sky or sky point feature that leverages the integration of smartphone sensors, so your gyroscope, your accelerometer, and your magnetometer, with precise GPS positioning to enable real-time spatial awareness. Now, these sensors, of course, are going to capture the device's orientation and movement, while the GPS does determine that geographic location. So the data basically is processed through a sensor fusion algorithm to calculate the smartphone's azimuth, its pitch, and its roll, accurately mapping the device's LOS, or line of sight. Now, Starwalk 2 does basically the same thing. In this case, the information aligns with the virtual celestial sphere with the sky, and it basically dynamically displays constellations and astronomical objects as that device moves. Flight Radar 24, again, it does basically the same thing. Instead of pointing your phone at the stars, you're pointing your phone at a plane in the sky. It tells you all about that plane. Now, overall, urban airspaces are becoming significantly more congested than they were just a few years ago, and this is due to the proliferation of those UAVs. And whether you know it or not, there are already a lot of UAVs being utilized within urban areas. The problem is we lack tools that allow for real-time spatially contextual visualization of these UAVs. Basically, we're limited to two-dimensional interfaces. This also limits situational awareness. Now, the project I'm currently working on and have been for the last 3 years aims to really bridge that gap utilizing augmented reality. So the core objective here is basically to develop a mobile AR interface that projects live UAV positions and predicted trajectories into a real-world three-dimensional environment. Now, I aim to support a bunch of different stakeholders, so operators, authorities, and most importantly, the general public, enhancing safety and enhancing trust in these urban drone operations. So overall, the system architecture is actually fairly simple. It comprises a data ingestion layer, a back-end server for path prediction and synchronization, and a front-end AR interface using Unity, built using Unity, supporting ARKit, and supporting AR Core. Basically, the system is going to utilize SLAM, so simultaneous localization and mapping, to align UAV positions accurately with a user's real-world environment. Broadly speaking, telemetry data streams are going to be ingested in real time. They're going to be processed by a path prediction algorithm that incorporates both physical constraints and no-fly zones. And then these points are going to be geospatially aligned with a 3D city model and finally rendered as overlays on the user's AR display, i.e. their smartphone screen. Now, the interface allows users to view UAVs, so these uncrewed aircraft, with contextual metadata. This metadata includes airspeed, altitude, aircraft type, operator ID, fuel levels, and flight paths are going to be visualized utilizing the color trajectories you see here. And it is a fairly versatile application, and there are a number of different socioeconomic sectors that have expressed interest in utilizing this application. So I've had a number of city transportation authorities express interest in order to visualize drone delivery corridors. And I've also had infrastructure teams express interest as well. Actually, probably the request I get the most is actually for people who manage dam infrastructure, it's an interesting kind of concept there. At any rate, while professional applications, these are certainly all well and good. Based on my doctoral dissertation research, it has been determined that citizens would be really thrilled to be able to use it to check UAV presence in sensitive locations. We don't want drones flying over schools, don't want them flying over hospitals, unless they have to, don't want them flying over prisons ever. And also citizens can become familiar with and engage with the UA ecosystem, basically fostering a sense of transparency and inclusion in the regulatory integration process. Urban environments, however, do introduce some complex challenges. There are some inherent issues that we have to address as related to urban operations and UAS. These are GPS multipath effects and high-rise occlusion. Of course, we can mitigate these utilizing dead reckoning as well as that SLAM technology we talked about earlier. Latency will be reduced utilizing predictive models and edge catching, and mobile device limitations are managed through adaptive rendering. Now, I'm working to prepare and carry out a number of different simulated and real-world tests. Anticipated findings do include showing a significant improvement in user comprehension and spatial awareness when compared to those two-dimensional map interfaces. Ideally, latency will be kept under 150 milliseconds with tracking accuracy at 1.5 meters or better. And finally, moving forward, my ultimate aim is to integrate 5G-based telemetry for lower latency, while also exploring crowd-sourced UAV detection using smartphones and automatic dependent surveillance broadcast, or ADSB out. I also recognize the importance of really privacy and ethical design when making airspace data publicly visible, so I think that a lot more research really has to be done to investigate those intricacies of the system. But comprehensively, this work really is intended to demonstrate the feasibility and the value of augmented reality for urban UAV visualization. It lays the foundation for a smarter, safer, and more transparent airspace integration framework. That's all I got for you.